Well, now we are into section 2, and the first question of section 2 is question 21. It says an electron revolves around a nucleus of charge JE. 108.8 electron volt energy is needed to excite an electron from n equal to 1 to n equal to 3. The value of Z is. Well, the question is obviously from the topic atoms, the Bohr model of atoms, and let's write the expression for energy required to excite an electron from n equal to 1 to n equal to 3 in terms of Z. The expression would be the energy E is 13.6 electron volt into Z square into, well, the transition is happening from n equal to 1 to n equal to 3, so it's 1 by 1 or simply 1 minus 1 by 3 square. We see its value is 13.6 into 8 by 9 Z square electron volt, and in the question, according to the question, this value is 108.8 electron volt. Well, solving, we find the value of Z square is simply 9, and which means Z is 3. So the answer to question 21 would be 03. Okay. Let's go to the next question now. Question 22 says, imagine that a reactor converts 1/3 of given mass into energy. If the mass of fuel consumed per hour in the reactor is 1.2 gram, then the power output of the reactor is 10 to the power n watt. The value of n is. Well, it is simply based on Einstein's mass energy equivalence. That is E equal to mc square. We'll use that expression, of course. So the equation mass energy equivalence is given as E is equal to mc square, where E is the energy produced when mass m is converted into energy and c is the speed of light in vacuum. Now here it is clearly given that 1/3 of the mass of 1.2 gram is converted into energy every hour. That means the value of power produced will be 1.2 by 3 gram. If I convert this into SI units, that means into kilogram, I need to multiply it by 10 to the power minus 3. This is m, and c square, of course, is 3 into 10 to the power 8 whole square. But this is the energy being produced in 1 hour, and to find the power we need to divide this by 60 into 60. Those many seconds are there in 1 hour. So now we get this value is in watt, of course. If we simplify it further, we will find that this simplifies to simply 10 to the power 10 watt, and which means the value of n is 10. So answer to question 22 is 10. Let's now go to the next question. Question 23 says, assume that each diode shown in the figure has a forward bias resistance of 100 ohm and an infinite reverse bias resistance. The current through the 300 ohm resistance in milliampere is. Well, this is a simple circuit involving diodes. There are two diodes, and if we look at the circuit carefully, we can easily say that this diode is in reverse bias, which means there will be no current in this branch, the branch having a resistor of resistance 200 ohm, and this diode, of course, is in forward bias. So there is forward bias resistance of 100 ohm here and 100 ohm here, so there is 200 ohm, and that will effectively be in series with this 300 ohm because this is infinite resistance. This will act like an open circuit. So the total resistance in the circuit is 500 ohm, and so the current in the 300 ohm resistance, I will be EMF, which is 20 volt, divided by 500 ohm. Now this figure will be in ampere. To get it in milliampere, we need to multiply it by 1000, and which gives us that the current is 40 milliampere. So the current through the 300 ohm resistance in milliampere is simply 40. So our answer to question 23 is 40. Let's go to the next question now. Question 24 says, if 2.8 into 10 to the power minus 6 is added to 3.2 into 10 to the power minus 5, giving due regard to significant figures, then the result in scientific notation will be x into 10 to the power minus p, where x is a number in decimals and p is an integer. The value of p is. So obviously the question is based on the operations with significant figures. We know that when two numbers with decimals are added, then in the final result, the number of digits after the decimal will be smaller of the two. That means the digit which has smaller number of digits after decimal, those many digits only will be retained in the final result. So using that, let's convert both the figures in decimals straight away, and if we do that, then we can say that 2.8 into 10 to the power minus 6 is actually equal to, so we take so that means there are 7 digits after decimal in the first number, and in the second number, which is 3.2 into 10 to the power minus 5, we shall have 1 digit less after decimal. So that means it is equal to 0.000032, and if we add the 2, we get 8 here, and then it is 4, it is 3, and there are 4 digits and 4 zeros before the decimal. So this is what we are getting, but we can only retain 6 digits after the decimal in the final result. So that means we have to drop this 8, and if we drop this 8, this becomes 5. So this we can say is equal to 0.000035 with proper significant figures, but we have to write this in the scientific notation, and so this is equal to 3.5 into 10 to the power minus 1, 2, 3, 4, 5, of course minus 5 only. So this is the result in significant figures. Now if you look at the question, the value of p is simply 5. So that means answer to question 24 will be 0.5. Let's go to the next question now. Question 25 says, a spherical mirror which forms an enlarged virtual image at 25 centimeter for a real object at a distance of 12.5 centimeter. The value of radius of curvature in centimeter is, well, it's a simple, straightforward, easy question from the topics ray optics, and that too from the mirrors. We clearly have the value u as minus 12.5 centimeter. The value of v is then plus 25 centimeter. We first find the focal length by the formula 1 by f is equal to 1 by u plus 1 by v, which is minus 1 by 12.5 plus 1 by 25. This will give us 25 minus 2 plus 1. So the value of f is minus 25 centimeter. The radius we know is 2 times f, so this is minus 50 centimeter. So the value of radius of curvature of the mirror is 50 centimeter, and so our answer to this final question is 50. Well students, with that we come to the end of this quick solutions. Hope you found the solutions helpful. I wish you all the very best for your preparations. Take care of your health, and bye for now.